Yes. Good morning, everybody. My name is Roberto Cavaliere from Neutech Park. I'm going to moderate this AI track. I see a lot of people here, so this demonstrates that AI topic is a very hot topic. So let me introduce our first speaker, a very a huge expert of AI, one of the most clever person have ever met in my short life, and he represents self-hosted large language models. So Chris Meyer, the floor is yours, and please.
Thanks for the nice words. My talk will be about these large language models with a very short introduction. Probably you all played a little bit with ChatGPT and the likes. And the point is here, my experience in trying to run this locally. So I went and DuckDuckGo'd a little bit about the open models, tried a few of them, and this is just my experience on what came out trying to run this locally. So without further ado, these are large language models as DALL-E thinks they look like. Very quick introduction. These things are basically deep learning models. Deep learning is around for some time. You have certainly seen image recognition, voice recognition. That's all mostly done by these deep neural networks. And since a few years ago, people started to try to apply them to natural language processing, and we got these famous large language models. This PDF will be available. There's a lot of links. I can't go into details in 15 minutes, so please have a look afterwards at the PDF and maybe follow some links. Basically, these deep learning of large language models works by feeding a large corpus of text. So that's typically Wikipedia, some scraped web pages into these deep networks. And that's called pre-training. So the keyword is here that you want to have a model that is pre-trained. We'll see that the training is the hard part. You can't do that on your PC, not even if you have a gaming PC like probably you students all have. You can't do that. You really need a lot of money to do that. But fortunately, some pre-trained models are available as open source. So what does these models do? If you take pre-trained models, it is actually quite simple. These models just complete sentences. So here, for example, I asked one model, Llama 2, to finish the sentence, compare apples and it will just output oranges. So that's all they do. There's nothing more than that. Now you say, okay, wait a second, I'm chatting with these things. How does that work? Well, that's also quite simple. It's basically just a huge trick. Here you see a foundational model, so just a pre-trained language model. How can we chat with it? Well, we feed this yellow text in it, and this is hidden. It's always there, also on the chatbots, but you don't see it. So you basically start bootstrap this model by feeding the start of a chat into it. And you see the green text is the first question then that comes from the user. In this case, I made the question. And the white text is then the answer of the model. So that's the whole trick. It's just text completion. There's really nothing more than that to it. And then I asked another question, I got another answer. Okay, this is a little frecciata to the SFS code. Okay, so the question you probably now have is, well, this is then a kind of a fake thing. We were expecting cool AI terminators and just got what they call stochastic parrots. So just a bird completing your sentences. Is this all? Well, not really. there's this thing called ChatGPT, and probably you're already using it to make some homework for you. I'm talking to the students, of course. We professionals would never do that. And so you probably have found out that ChatGPT is much more than a stochastic parrot. No way it's just that. Have a look at this. This is a problem, a text problem. It was used in a high school here. It was never published on the internet, so it's not something that ChatGPT could have a look at. And I asked it to solve this. I will not go into the exact problem, but it could easily solve this. So there is obviously much more than text completion going on here. The system could do all the unit conversion, apply the right formula, change the formula. Basically, it's 2, 3, 4 steps of reasoning that was done here. So how does that work? Well, we don't know. Is this AI? Probably it's some sort of start of real artificial intelligence. What happened is here that when these models grew larger and larger, something interesting happened. There was this phenomenon of emergence of abilities that were not planned to be there. Researchers were actually surprised that these models could answer problems like this one. This is kind of not a planned thing. People experimented with these models for natural language processing, not for reasoning. Reasoning emerged spontaneously. And here's some very interesting links. I really invite you to look into this, especially the last paper here, Sparks of Artificial General Intelligence, Early Experiments with GPT-4. This is quite interesting on what strange abilities they found in the model that was really not expected. Okay, so yeah, well, everything is fine then. We have this cool new AI. Okay, well, there's a bit of a problem here. The problem is in the word large. These models are incredibly large. As a comparison, here at NOI, I did a few years ago a talk about image recognition, about face recognition, and the model I showed that does face recognition very well, better than me actually, was 20 megabytes in size, 20 megabytes. Well, these models here, this B stands for billion, that would be an English billion, so a giga. So for example, GPT-3 is 175 giga parameters. If a parameter is 16-bit, that's more than 300 gigabytes of size. So that's much more than 1,000 times larger than the image recognition models. They are really huge. That is a bit of a problem because training them costs a lot of money. We don't quite know what OpenAI does because they do things quite secretly. But as an example, here's a model I'm going to show you right now. I estimate it costed about $1 million from the order of magnitude. Maybe it was less, maybe more, I don't know. But that's an estimate to train it, okay? So we somehow rely on somebody that has money to pre-train us a model, and then we can use that model and do things with it. But this is currently maybe the biggest problem. Of course, it's not just training costs, it's also, as was said by Carlo Piana before, the access to the text material to train it. Yeah, you can take Wikipedia, but you also need other contents, and there might be copyright problems, so you need a huge entity that shields you from copyright claims and all those kind of things. So what are interesting open models I found? You see this strange graph here. So there's llamas involved somehow, and pajamas. So I found a few. Here I mentioned Red Pajama is a nice project. They do everything completely transparently. They have they made, first of all, a nice corpus that is released as a free license, so you can really reproduce their work. You can do the training if you want to. Problem is, right now they have a model with 7 billion parameters. That's at least an order of magnitude smaller than the cool models by OpenAI. So it's quite small yet, but they are continuing to work. Stable diffusion, the guys from the image generators also did something. They have a small model also. But these are basically too small. They can't really reason. You can use them to do text completion and interesting thing, but reasoning is not there yet. They're probably too small for that. So future models, Llama 2 is of course now the most popular model. That's by Meta. Meta has a lot of money because you are using Facebook the whole day. So they had the resources to train a 70 billion model. That's of course quite interesting. And it's a very permissive license, but unfortunately it's not an open source license. So you can basically use it. You can also use it for your company commercially, but you have to read the license because there are some catches in there. And finally, one of the latest models, it was just released this summer, well, also Llama 2 was released this summer, is Falcon. Falcon is done by some institute in Abu Dhabi, the United Arab Emirates, so also people that obviously are well funded. And they have a 40 billion model that works quite nicely and is Apache 2 license. So that's really open source and you can use it, you can do everything you want to. In September, they released a 180 billion model. So now we are talking. Unfortunately, they did not assign this the Apache 2 license, so the 180 billion model is unfortunately not yet available as open source. So everything is done. Just follow my links and host these. Well, there's the room is on fire here because these models are, I did say that already, large. So for Llama 2, you need 140 gigabytes of memory. Now you're laughing because you're saying my gaming PC has that. Problem is, normally deep learning is done on a GPU. And even if you have the most expensive consumer GPU that exists today, you don't have 140 gigabytes of RAM. So you need to do something. There are at least 3 strategies. You can rent these expensive NVIDIA cards like the A100 or the H100, but they are really expensive. They cost a few $10,000 a piece, like $30,000 a piece or something like that, and you need a few of them to cover that memory. Or you can use, of course, smaller models, or you can use the CPU. And a very interesting project I found is Georgy Gerganov's Llama CPP, which is a very nice piece of open source software that can run all kinds of models, not just Llama, despite the name, on everything. It can use the CPU, it can use all GPUs, it can use NVIDIA, but also, for example, the GPUs on the Mac. It is really very generic. And mostly it does something very interesting. It can compress models to a few bits per parameter. So those 70 giga parameters of Llama 2 then become compressed to 6 bits. They stay into 50 gigabytes of RAM, so you can run them on a quite a normal desktop with a bit more RAM, 64 gigabytes of RAM. You can run them. Okay, so time is running out. You can get the models from there, Hugging Face. Look at the links if you want to try this at home. Let's run the models. I'm an AMD fan, so please applause from the gamers that use AMD. And run it on 16 cores of this bit more expensive server processor, but probably your Ryzen also goes well. You don't really need a huge chip. A gaming PC should do. I tested it. Here's some command lines I used for the chatting, first of all. Here's an example of chatting. This works quite nicely. It can answer the facts correctly. It works. It can speak in German, Italian, and English, no problem. That's the languages I tested. Probably it knows even more. I've seen Llama 2 has a bit of a problem with German grammar. It messes up a little bit the cases and stuff, but it's basically there. It's really working quite nicely. Here's Falcon, which is also good. I had some problem running the larger model here. I did test the text problem before. And neither Llama nor Falcon at these sizes could do it, but Falcon 180B could do it. So you see, somewhere at 100 giga parameters, the magic starts. Okay, time is over. There's some benchmarks here you can look. The outlook, there is another talk in February 1st here at NOI, where I will show a little bit more about how I integrate this model with this retrieval of information, so they can't just output what they have been pre-trained on, but they can output information about some documents you feed into them. Okay, thank you. Sorry for being quick.
Thank you, Chris. We start again in 4 minutes. Okay, let's start again with the next speaker, Björn Schiessle from Nextcloud, and he will present some unknown features of Nextcloud, if I got it well. Please, the floor is yours.
Exactly, thanks a lot. First, I want to apologize to you. Originally, I wanted to talk about the Nextcloud AI features, but as you have probably seen in the main track, we already had a quite nice talk about it, so I decided together with the organizers to switch the topic and talk a bit about Nextcloud unknown features. Normally, I do this as a demo, as a live demo, so it's really also for me interesting to see how this works out as a presentation with a lot of slides and pictures. Let's skip the boring part about me and start with the Nextcloud features. Nextcloud becomes quite huge, and even for me who are using Nextcloud now for 7 or more years even, sometimes in my day-to-day work I stumble across some nice small features often, but they make really a difference and I know them, and the goal is to show you some of them. And maybe there are also some aha effects for you and they say, hey, I never saw this before, a really nice feature. One thing, if you use Nextcloud files, you probably also share a lot of documents with your friends and your colleagues, and you might sometimes be annoyed that all these shared documents end up in your main folder, in your root folder of Nextcloud. And there is something you can do about it. If you go to the personal settings, you can first choose the target of shared documents to send them to a subfolder instead of your root folder, and you can also decide if you get a lot of shares that you want to accept them and decline them before they end up in your Nextcloud and be synced to your devices. When you decide that Nextcloud that you want to accept and decline the shares before they arrive in your Nextcloud, whenever someone shares with you, you will get this nice notification on the browser, but also on your mobile and desktop clients. You see that someone shared something with you, and then you can decide if you want to accept and or decline the share. If you missed the notification, or if you if it's not there for whatever reasons, in the left-hand sidebar, you can open the share overview, and there is an area which is called pending shares. So whenever you missed one of the notifications, you can go there and check all the shares you not accepted now. You can review them there and decide if you want to accept or decline the shares. What's often also people don't know, when you receive a share, it ends up in the folder you want to have them, and by default the share has the name, like the file or folder is named by the owner of the document. Sometimes there's a small bracket 2 or something if you have the same folder or file already on Nextcloud, but most people think these names are static. But what you can actually do, if you can rename this folder or this file however you want, and you can also move them around. You just go to the three-dot menu and click the rename button, and then you can change the name of the folder. And now a bit surprised if the 5 slides are updated or not. They are updated, really nice, because I sent a small update yesterday evening. Then when you rename the folder, you see at the top how it looks for the owner. It's still the same name, but for the recipient, you would just change the name, it has the new name. Or it's in the new subfolder, you move the file, so you can organize the shares you want, you receive the way you want them in subfolders and so on. And you don't have to worry that you break the names or the location for the owner of the file and document sometimes, which is something that's really surprising sometimes to the users because they don't expect it. But if you are a Linux user, you can think about it like a mount point. And you can change the mount point for you to look the way you want, but it doesn't change the name and the location for the owner. That's also why it's really important. If people send around links for files, they often just copy the URL from the address bar of the browser. And in the URL, you have the path encoded for you. But the path for you might be not the path for the recipients, because as I just showed you, the recipient can rename files and shares and can move them around. So always go to the right sidebar and use this internal link if you want to pass something around in an email, in a chat, whatever, because that's a link which which contains an ID, which will be always resolved to the right location. So never do the short pass and take the URL from the address bar. Always use the internal link, and then you will be sure that the recipient can work with the link. Also, when it comes to sharing, what people don't realize, sometimes I hear people saying, hey, I have so many colleagues and friends and coworkers. They share tons of stuff with groups and with people, and I can't manage it. I have so many also group shares I no longer care about. The project is over, or I left the project, and it's still there, and I have to ask them that they unshare it from me. No, you don't have to ask them. You can unshare shares directly from yourself. And that's what you see on the left side on the screenshot. If you use, again, the 3-dot menu, Where you normally see the delete option for shares, you have this leave the share option. You just click there, and then the share disappears from your file listing, your client stops syncing it. So when you have a lot of uninteresting shares in your folder and you want to get rid of it, you don't have to ask the owner to please unshare it from me. You can do it by your own and clean up your folder. And maybe you do it sometimes a bit too fast. You unshare something and then you realize, oh, damn, the project comes back to life, whatever, I still want to have access to the file. And because the owner still shares with the group you are a member of, you can go to the pending shares, like with the accept and decline share operation I showed you before. And there are also the shares you unshared from yourself. So if you unshared something from yourself by accident, or you decide later, I want to have it back, I still need this project folder, whatever, go to the pending shares, you will find it there, unless the owner decided to unshare it from you, and then you can just pull it back and you have access to the same share again. Also something people don't know, Nextcloud has a versioning system, so if you edit a document, you get multiple versions out of it, and Nextcloud also deletes versions automatically. And especially if you work with, for example, a project plan, maybe an offer you want to send out to a company or whatever, you want to say, okay, that's the final version, that's the final project plan, the final offer, the final invitation to my birthday party, whatever, what I send out. And in the share view, if you click again on the three-dot menu, so you see the three-dot menus are really important in Nextcloud. There you'll find many exciting features. There's an option these days to name a version. So you can click there, and then you can give this version a name. For example, final offer I sent out, final invitation to my birthday party. And then this version gets a name, as you see in the right sidebar. It has now the name here attached. And these versions are kept out from auto-deletion of versions. So you can also make sure that then this important milestones of a project, of a document, will always stay in your history, and you can easily find them because they have these nice names. And of course, you can also compare versions. Through the three-dot menu, you can say, compare these versions with the current version, and then for every document where Nextcloud has a viewer, this can be Nextcloud Office like here, this can be a picture, this can be a text document and other stuff, everything which every document you can view and edit directly in Nextcloud, you can here have this nice side-to-side comparison. That's really one browser view, so I don't cheat it and put two browser windows next to each other. That's really just one browser window, and you get these two documents next to each other, and you can see what was the difference from this version to the next one. Was also super handy, quite new feature. I really wonder sometimes how I could live without it. You can set reminders on documents, but also on chat messages and other stuff. A colleague shared a document with you, and you want to review the document or edit it, but you don't have time now. So what you do, you have to write it down on a piece of paper that you want to go back to the document. You create a to-do item in your to-do list, whatever. But you can also go to the Nextcloud, again, three-dot menu, and say, I want to set a reminder. Tomorrow, next week, a custom date, and then at the point in time, this document will pop up as a notification to you again and say, hey, there was this document, you wanted to do something with it, and then you can click on the reminder, on the notification, be directly back to the document, and can do the review, the editing, what you want. And as I said, this goes for every data you store in Nextcloud, so you can do the same for chat messages if you want to react to a chat message later, because you don't have time now. Just set a reminder for the chat message, and the chat message will come back later, or you can do the same for an email if you use Nextcloud Mails for all the features you have. Quite nice for the more technical people. You can create mermaid diagrams in Nextcloud Text and Nextcloud Collectives, which is our knowledge management system, something like a wiki. So the ones who know mermaid diagrams, it's basically a text way to define diagrams. You see it here, the text form. It's just with arrows, you define the relationships. And then it's rendered as a nice-looking diagram. So if you use a lot Nextcloud for documents where you also have some planning, some projects, some technical drawings, can have these nice diagrams there, and they're even rendered nicely in Nextcloud. So now I talked a lot about Nextcloud files and sharing, because as probably you know, that's still one of the main features of Nextcloud, but also the other areas have many of these really nice integrations and nice features. Many people don't know and miss them in their day-to-day work. And one thing is Nextcloud Talk, our chat and video conferencing solution. Most people, most of the time, just go to Talk when they want to chat with someone. But you can start a chat from everywhere where you are. if you use Nextcloud, you see in all different locations this icon from the users. If they share some document with you, if you edit together already a document, you always see the icon from the people who are in the document, who shared something with you, who collaborate with you. And whenever you see this icon, you can just click on the icon, and then this small menu you see here pops up. And one nice thing, you can see the local time of the person. So if you have a distributed team across multiple countries, you see if it's a suitable time to contact this person, or it might be middle in the night for them. And if the time matches, you can just click the talk to John in this case, and then you jump to talk, and you have this one-to-one chat with him. So you don't have to go to talk, search the person. When you decide that you have to talk with him, just click on the icon and start a conversation with the person. Also, what's quite nice to talk, which is relatively new, so that's why many people miss it, Nextcloud also now supports breakout rooms. So if you have bigger group conversations and you have maybe some brainstorming sessions and you want people to discuss in some small groups, same like you know it from other solutions, you can create breakout rooms as a moderator, send people to the breakout rooms. As a moderator, you can jump between the breakout rooms, join the discussions, and afterwards pull everyone back again. So maybe this was for you a reason not to use Nextcloud Talk until now, but at least that's what I hear often. That's one of the reasons why people jump to a different solution if they need this kind of breakout rooms. Now Nextcloud has it as well, since 1 or 2 versions, and you might not have noticed it. Yeah, here you see a little bit how it looks like. Then you have on the right sidebar as a moderator, you see the rooms, the participants, and you can also jump between the rooms. Another thing, talking about talk rooms, which is quite nice, you can define talk rooms as public rooms, which are searchable in the directory of Nextcloud Talk. So each Nextcloud user has a public listing of available rooms and can join them. So if you organize your organization in different departments, in working groups, in projects, you can have these projects rooms, these department rooms, and make them public so that people can use on the left-hand side, you see this 3-dot menu again, where you can say join open conversations. Then you get a nice selection window where you see all the open conversations. And as a new people who join the organization, for example, you can say, okay, I want to join the engineering team, the marketing team channel, and they can find these channels and join them directly without getting invited directly. Smart Picker is something super useful. You can, in Nextcloud, if you type a dash in the chat, but it also works in the text editor, you get a Smart Picker where you can do all different things in Nextcloud. One is, for example, you can, if you use Nextcloud Deck for your project management, you can select a deck card and send them directly into the chat. And then it's nicely rendered like you see here. So it's not just a text link, but people directly see what the card is about. Or what's also really nice, if you have a meeting and you discuss some stuff and someone says, hey, I have something in my head, I want to quickly draw it that people understand it. There is this draw a sketch picker. You can choose this. Then you get a nice picture drawer. Sorry for my lack of creativity. It's not the most creative picture, but you can draw something and afterwards just send it in the chat as well. And as I said, this Smart Picker also works in Nextcloud Text and so on. So if you want to add it to a wiki page, to a text document, these pictures or these links to other resources, quite nice. Just remember, always type the dash, and then you get a Smart Picker for all the stuff which is available on your system. As I said, it works everywhere in Nextcloud. The same way you can, as I showed, that you can share a deck card into Talk, you can also turn any Talk message into a task. You know it, you talk to people in a chat, and often tasks came up you want to follow up on. So just use again the 3-dot menu and say, turn this message into a task. Then this dialog will come up where you can say in which board this task should be put. You can directly define some labels, assignments, due dates, and then this task directly shows up in your project board. So you don't have to do it manually, just choose the chat message and say, move it to the deck board. So I need to hurry up a little bit, but that's fine. Nextcloud Circles, you can define custom groups and then pull people in you want. Don't have to wait for the administrator to do it, and share with them and collaborate with them. What I want to show you, which is, I think, also a super nice feature, is appointment booking. You can have a calendar link sent out to people. You can, as you say in the right screenshot, you can define the time slots, how many time slots people can pick, which calendar should be checked against collisions of your appointments. and then you send it out. People click on the link. It looks like this. They see all the free slots. They can book appointment for you, and then you get a notification someone booked the appointment. They get the invitation as an email, but they also can accept it once more. Nice thing is we directly create a talk link next to it, so the invitation also contains directly a link to the talk room where you have the meeting later on. And that was on the second finished.
Thanks a lot. Let's make some minutes break, and then in a few minutes we start again. Thank you.
From a textual description. So basically you have a platform like this, and you provide a textual prompt at the top here, and you can just mention what kind of picture you want, whether it's a 3D render, a typography, cinematic, or painting styles, and you can basically create images from textual input, and all for free. The next AI tool we have is Vectorizer AI. Many times when we are working with images in web development, in websites, and while building apps, many of the icons and images are of low quality, and you can use this AI tool to basically enhance your image and turn it from low resolution images to high resolution images. You can even see that it's the same image type and the same dimensions, but the quality of the image has been greatly improved because the artificial intelligence models the individual pixels and creates a higher resolution version at the end. So the next, we look at some of the research tools. These are tools which I have personally used. So the first one is Heuristica, which is a great tool for mind mapping. So if you have to learn a lot of hard concepts and understand a lot of different things, you can use this tool to basically select a topic, and then you can add one of these blocks, and it will create, for example, for machine learning, it will create the concepts, and if you select a block like what or how, it will automatically generate these for you, and you can just improve the understanding of the topic with these mind maps, and it becomes very easy for you to understand these harder concepts if you're trying to learn something or conceptually trying to understand a research paper, for example. Next one is one of my absolute favorites. So it is called ChatPDF. You just drop in a PDF or a long form manual, and you don't have to basically read through the entire thing. You can just ask questions and retrieve the answers you need directly with this tool. The next is Forefront AI. Now another use case is, let's say you have some images. For example, in this example, you have an image of a chemical structure, and you need to know more information, what it is, what it does, and what not. So you can just chat with this image, and it will give you information such as that this is a graphene sheet. It has carbon atoms bonded to 3 other carbon atoms. It has high electrical conductivity and thermal conductivity, et cetera, and you can conversationally improve and learn more and chat with images. The next tool we have is Gamma, which is a tool, it's a completely free tool which you can use to create presentations out of just textual prompts. So I put in there AI tools for the modern world, and it could already create 8 slides for me with relevant information, and you can just use these additional tools here to improve your presentations and create it as you want. So it's a good foundation if you're trying to create your own presentation for some things. I didn't use that for my presentation, but yeah. Next is speech and audio tools. So let's look at some speech and audio tools that we have. The first one is 11 Labs. So basically what it does, simply put, is there is some textual content which you have, and it automatically converts that text into an audio file which you can download. So if you are running a company where you have a lot of manuals and you have to use these manuals to create videos for employee training or onboarding material, then you can just use this tool to put the manual texts into this tool and create videos, audios for the videos and your onboarding training. The next one is for people who are involved in music production or work with anything to do with audio files. So this is a tool with which you can separate vocals and other instrument tracks that can be associated with the music. So let's say you have a music with many different tracks of many different instruments and the vocals. You can use this to separate all of them and use it for your music production. So if you're doing any kind of job that involves audio handling or music production or training audio-related machine learning models, so this is a very important tool. Now we will look at some fun tools, starting with AutoDraw. So the last speaker said his Stickman wasn't so good. So basically, you could have used this tool. So I drew a little hut and a path, and this tool automatically generated a drawing for me. So basically, I can just delete this and you use this. So it's a fun tool that you can use, maybe with your kids. Next, we have Sketch from MetaMode Lab, which is another AI tool using drawing. So basically, you can create a little stick figure or a hand-drawn drawing, and you can add animation. You can make it dance, add funny moves, jumping, walking, running, and make a whole animation out of it. So yeah, one more fun tool for you. Next, we have Flare. So if you're a product developer or a product manager who's responsible for product photography for professional ads in print and media, this tool is very useful. So basically what you do is you take a picture of your product that you want to use, you drop it in this tool, and then you give it a prompt. Like here, in my case, I said, perfume bottle on a table surrounded by wavy fabrics, and it created this nice professional-looking product images that they can use in print and in media. So this is for product managers out there who might find it useful. Next, we have Runway Generation 2, which is a tool that you use to convert textual descriptions into video. So here, I have a textual prompt, a man sitting in a suit in a dusty old room, thinking about something. So it could generate a video for a few seconds, and potentially you can use it to create more lengthy videos and create your own short movies or whatnot. The next tool is GPT-XL. So if you work with Excel sheets a lot in your workplace or somehow involved in a lot of Excel operations, then this tool can be very useful for you. It can generate spreadsheet formulas and app scripts and SQL queries. So yeah, that's another useful tool. So now we are going to move on to 100% open source tools. So it means that not only are these free, you can download these artificial intelligence models, tweak their hyperparameters, fine-tune them, and create your own applications out of them. So one of the most popular tools is ChatGPT, and there is a completely open source version of that, which is Z for Chat. You can download this model, train it on your own data, and create your own ChatGPT, basically. And It also has a UI, which is similar to that. The next tool we have is Fast Stable Diffusion, which is another open source tool where you can download the model, add your own training data of images, train that model, and create your own version of Midjourney or other image generation websites. Yeah, there's also a UI where you can basically fine-tune hyperparameters and set your own seed and yeah, whatnot. So the next tool is Face Recognition SDK, which is a tool you can use to add face recognition in your applications. So here in this example, you can see that this is a tennis player with 2 images, and with 86% confidence, it knows that it's the same image, and you can basically use this SDK in your applications to add face recognition feature in your applications. What? No, that's not the end. Some technical issues. Okay, so there were 2 other tools, but anyway, I will leave with you with the final thoughts that I think AI is here to stay. Okay, we have something. No, we don't have something. Okay, anyway, so my thoughts are that AI is here to stay, and the more we start getting comfortable and start using these tools, the better it will be for us to work with it and yeah, help us advance this technology for our communities. And okay, we still have 2 minutes, so I think I can still make it. So the next tool is Distal Whisper, which is, again, a tool where you use audio and you can transcribe them using an AI tool. So let's say you have tutorials which are 2 hours long. You can just drop in an URL and get the textual transcripts and summarize that and use it in a more efficient format. The last one is the ProPainter tool, which is a tool where you can have videos and remove objects from the videos automatically without using Adobe Premiere and other paid tools. Okay, so yeah, and we have many more such tools which we will discover as time passes. And yeah, one important disclaimer is that you can do a lot of unethical stuff with this AI tools, and I urge everybody to be mindful of that and only use AI tools ethically. Yeah, because with great power comes great responsibility. And final thoughts, yeah, again, I would repeat myself. Let's embrace AI and try to use it for our benefit and for the betterment of our communities. Thank you very much.
Thanks a lot for this nice overview of all a lot of available AI tools. So we start again in a few minutes. Thanks a lot for your attention. Okay, let's start again with the next speaker, Enrico Zanardo of Beats. Topic, inductive logic programming. Please, the floor is yours.
Hi, good morning, good afternoon to everyone. Sorry for my voice, but it's gone yesterday, and I hope to be able to finish my presentation today. As I already said, I am Enrico Zanardo. I'm a researcher at Beats. And today we are looking on optimizing software performance using, let's say, inductive probabilistic programming. Means that we have tried to use this language to better understand what machine learning models could be analyzed. Oh, yeah. We passed through these 5 dots, like the context and motivation why we are looking on doing this research. We will see a little bit about what we are doing, our related work, and I will demonstrate or show you even also a very dummy, simple example of the problem, and then we will look on some results that we have already achieved, and then I'm going to conclude with very easy conclusions. About the context, we are not in an environment where data sets and models are really one near to the others, means in the same machine. We are in an environment where we want to have data sets that are in distributed places. They are distributed, means that people can have data sets that are not in the same place. And we want also that the computation of the training of our machines to be done in a distributed and decentralized ecosystem or network. Moreover, using the inductive probabilistic or inductive programming language, we want also to have something that can be explainable, means that we want to know what the machines are doing. And in Squares, there are like the research questions that are combined, or what we are looking to get an answer to those elements that are inside to our context. Precisely, research question 1 is about if it is possible to efficiently train a machine learning models in a decentralized and distributed network without having to be the owner of the entire data sets. And this is why normally single node machines are the environment where the model is trained, and it's quite difficult nowadays to host everything because we know how huge are models or how huge are even the data sets. Right? And the second one is a little bit more advanced question, because it's possible to turn machine learning models human readable. It's possible to look on what is the real values that are inside there, why the function, the ReLU function was activated. It's possible to understand, humanly understand. And for that, we was looking on what is existing in the market. More precisely, we was taking into consideration the MapReduce and RIAD parts or distributed execution engines to start from there and look on if it's possible to use that kind of functions to start with our research and be able to build something on top of them. But we have seen that they are relying more in data replication, means that to ensure the fault tolerance of data, they are reproducing a lot of times or distributing a lot of times the same data around the network. They are broadcasting a lot of information, and the information is proceed more than once. And moreover, they are not specifically designed to be able to make or to run in a distributed manner. They are built to be executed inside to one single machine. Saying that, we have look on what is in the market that we can apply to this MapReduce and RIAD functions or elements. And we have seen that it's possible to add on top of them some techniques or tools, like the QGL MapReduce, that is trying to put like a cycle graphs inside to the process to give to the elements a way to recognize where the processes are gone around the network, where they are distributed, and how we can track that a single execution or a process is really executed with some data. Then we have had also a look on head loop. But we have seen that this kind of features is trying to reduce the overhead of trying to, again, every single time to execute or start iteration from scratch, because I've seen some data that was not seen before, even if that information was already trained by another node in the network. And then also with Apache Manhound that is trying to distribute or add the MapReduce functionality in a distributed environment, right? But those features are different from our approach for the following reasons. They do not provide a transparent fault tolerance, means that you cannot be sure which is the process or the element that was, I don't know, means like it was not any more track in the network. They do not support task dependencies graphs, means that they are not able to know if the model was executed in a consecutive manner, or if the model was possible to, let's say, divide in chunks, and some chunks of that can be distributed in the network and run in a parallel way. And we have seen also a lot of job latency doing execution of a model or training of a model in a distributed network. We have also used like Pregel and Piccolo, but we have seen that they have some problems based on our research on the computational and the fault tolerance involved checkpoints, means that they have to check every single time what was done and what is still to be done. About the research question 2, explainable is not just something that was coming in our hands, but is something that is also coming from the GDPR regulation, means that a subject must have a reason or have some explanation on why some decision was taken from AI that was executed. To be more precise in this, I will take like an example, a very easy example of a data set. As we can see here, the husky-wolf problem, to just classify two simple things, if it's a husky or if it's like a wolf, and it's not, is going, let's say, very well, right? Because we have seen the real that is working pretty well in the classification. But sometimes the system is doing some, finding some true positive or false negative, and we want to know why. And if you look on why, we can see that the reason why there was this error is because the model was taking into consideration the background of the picture, not the face, not the animal itself, just the background, because all the other pictures was having a background, a white background. And we want to know, we want to have the explanation on why there was this error. For doing that, we have used, our approach was using inductive logic probabilistic programming to combine logic and data mining. We want to enabling automated data-driven decision to making software optimizations. We want also to optimize the software in the way that could be executed in a distributed manner, right? And right now, just to be, again, more efficient, or probably to give you a better overview, I'm going to show you a very easy example that needs to take in consideration just 3 files that most of other companies in the same fields of inductive logic programming are using, like an example files, a background knowledge file, and a bias file to reduce, is used as a filter to not spread too much the computational power of the machines. Those are the examples. One is like just with some very easy elements that are telling us that is a positive, sorry for that, is a positive sentence where that means that it's true, and then we have also some negative sentences telling to the system this is not true. We can distinguish what is true from what is not true. And this is our example, is our context. From that, we have also, we can give to the machine a knowledge. Means we can tell to the machine, hey, we know that Anne is the mother of Amy. The father, Kevin, is the father of Amelia. We know that. I'm giving you those information to the machine. And the machine must be able to know what I'm talking about. But for sure, as a human, I'm able to understand what is written here. It's not so difficult. It's not so difficult like looking on the execution of each epoch of the direction of the training of a machine learning model. And then we need the third file that is very easy. It's just reducing the context of our exploration. And then at the end, when we are going to run our machines or our model into the distributed network, we are coming out with those, let's say, rules, functions. The machine is able to generate for us functions that are like logic functions that are always true. Means that the machine can find for us information that are information that probably we can also do not have from the beginning. Means that the machine is able to find logical interaction or logical mapping that even the human was not able to think about. But since that the machine has a lot of computational power, they are able to do that, right? And as we can see, this is a very easy example with a very sure or very small data set, right? But it's even like a machine learning model. We have the precision, we have all the information about true positive, true negative, and so forth and so on. But what is more interesting here is the fact that it's explainable. I can explain to you why there is an error, or if it's not an error, or I can tell you that all those 4 sentences are really true. And that is probably our biggest achievement. The results, actually, with our research right now is about having a dynamic control flow. We can be able to determine which machines are involved to the computational power. We can be able to define a task dependencies to define which process could be executed in parallel from which one that cannot be executed in parallel. We are having like a transparent task forums, means that we know exactly what kind of piece of data is sent to which node. We are working a transparent network scaling, means that machine can join to the network. It's a distributed and decentralized network, and we can logically explain what is happening inside of the models, right? I'm going to close because I'm right now really approaching to the finish of my time. To conclude, this approach enables clients to run explainable, interactive, recursive algorithms in a parallelized with transparent fault tolerance and transparent scaling systems. We can adapt those technologies in an environment that must not be part of a single company. At the moment, it's like designed for coarse-grained, all right, for simplified versions of algorithms or models, but is working pretty well. And we have seen that in comparison with other systems, at the moment, if all the data of the dataset fits into the RAM of machines, probably Piccolo is a better approach, is more efficient rather than our application right now. If Jobs shares a lot of data, probably OpenMP is more appropriate right now because we are talking and discussing and sending messages between the TCP/IP protocol, right? For better scalability and performance, it's better to use MPI. But for the rest, probably we will try to do our best in the research to compete and probably overhead those points that we have right now. And that's it. Thank you for your attention and very much. Yeah, thanks a lot.
Thanks a lot, Enrico. Since we have still 1 minute left, we have time for one question, if any. No? Okay, if not, let's...
Interesting, right?
Yes, it was for sure. So a couple of minutes of break and then we go on with the next speaker. Thank you, Enrico. Okay, so next speaker is Paolo Rota from the University of Trento. This time the topic is Open Vocabulary Framework for Language and Vision Models. So please, Paolo, the floor is yours.
Yeah, thank you for the introduction, and thank you for coming to my presentation. Yeah, today I just want to add a couple of cents of, according to our topic of research about large language and vision models. So, first of all, I just want to introduce that we are mainly working on computer vision topic, okay? So what is computer vision? Well, a lot of stuff, right, that involves images, videos, and so on, but let's say the queen, task is to recognize images, right? So how does it work? Well, we have a big model, right? We have a lot of data with supervision, so we have labels for this data, and we train this model trying to, make this model understand what is the right class that we want to output, right? So eventually we have our model, we train it, and we have our final result that is a set of classes. Of course, these classes need to be available at training time, so we need to have a set of data that is available at training time so we can train our model. So this is a constraint. Well, the arrival of these large language and vision models kind of relaxed this constraint, right? So new models such as, I'm mainly talking about CLIP, I don't know if you know that, but it's a model that is composed by two different pieces. One is an image encoder and the other one is a text encoder, and it is trained with web scale data, so a lot of data, and the goal is try to align the representation of images and the representation of text, making the two modality close to each other as much as they can, right? So the goal is to align semantically also the two, basically the multimodal models, okay? So the goal here change a little bit the task in the sense that at this point we can define classes at test time. So we have this huge model that knows a lot, right? So we can basically insert our image of our nice Casovari that he wants to be recognized as a Casovari, and we just pass it through the image encoder, right? And we have this, what we call embedding set of numbers. And then we can define a set of classes at test time, so it doesn't have to be involved the training into this, and we can encode from the text encoder all those classes, right? The goal here is eventually to basically see how close these vectors are to each other. We take the highest, and it's likely much to be the right class. At this point, right, we are able to use a large language model, right, to do basically a classification where the classes are not known at training time, okay? So this is a very nice propriety of language models. But what we try to do in our group is, okay, let's try to make it harder, okay? We are not happy about simple stuff. So why don't we try to do something that doesn't even require a vocabulary? So we don't want to submit classes, okay, at test time. We want that our model just proposes a set of classes, right? So we want to relax even more this task. So the problem, of course, is more complicated, right? So we have a huge search space because we have not one class, we have a lot of, we can have potentially all the vocabulary of English, for example. Of course, this is a problem of fine-grained, okay? So it's the picture of our nice Casovari can be also classified as a bird, which is correct, but our Casovari wants to be called Casovari, right? And, but if we relax this, of course, the categories at test time are not needed anymore, okay? Well, you would say, right? I mean, you are talking about a lot of nice propriety of these large language models, and of course, we have to discuss also the bad sides of these large language models. First of all, they are trained with a lot of data, like web scale data, which is a lot of data, right? But foremost, I mean, also the previous speaker, they also said, guys, these models are trained with a massive amount of hardware requirement, right? So just to give you a few examples, Florence needs 512 NVIDIA 800, lot of GPUs. DALL-E from OpenAI, again, a lot of 16 gigabytes NVIDIA V100. Again, Clip, the very same Clip that I mentioned before, is trained with 592 V100. And then so on, Coca, 2,048 TPUs for 5 days. Again, 1,500 TPUs for 15 days for Flamingo. I mean, just to give you an idea that, you know, this set of hardware is hardly, you know, doable for an academic researcher. So how do we fight these big monsters, even if we know that our size is that one, right? So our nice Kasuvari consulted with us and he said, well, I want to be called Kasuvari, I don't care. So we had an idea. Why don't we train at all? You say, well, come on, wait. These guys training like for days, ages with huge machines and so on, and you don't train at all. Well, yes, but you know, those models are there, are trained, right? Why don't we do a good use of those models, try to, you know, change a little bit the paradigm, try to, you know, use it in a different way, try to get what we want without training. Okay, let's try to see that. And we proposed our model, okay? Our model is composed in 3 phases, okay? There is a first phase in which we propose the vocabulary on the fly. So at the beginning, we have our image that will be encoded through Clip. We are using Clip for everything, but we can use whatever large language model that includes videos and images and text. And we try to retrieve a set of captions from a huge caption database. So we have a huge caption database where each caption is encoded through Clip, through the textual encoder of Clip, and we just check, you know, we take the closest one, okay? This is fairly simple, pretty fast. You can do it on your laptop. It's super easy, right? And we can retrieve a set of captions. Those captions, of course, are not for the image. They were meant for another image, but who cares? If they are close, we can use them, right? So we take those captions, and then we do some simple post-tagging and to extract some interesting information, such as names, for example. And then, after this filtering, we have our set of our vocabulary that is, let's say, extracted on the fly. Okay? What do we do with that? Well, we use the 2 encoders, one, the visual encoders to extract the embedding of our image, and then we extract the textual encoding of all the captions that we had. And we encode also all our words. So we do a 2-step approach in which we check the closeness of the embeddings between the words and the image, and the words and the text, okay, of the average of our captions. And then this scoring is then eventually melted into one single histogram, okay? It's plain and simple. So by doing this, we are able to create, you know, a proposal of a possible class of our image, and we also have a few different proposals that we can rank them. So the results are kind of interesting, right? Because we tested it against a huge model. Blip2 is a very recent model, okay, that has been released early this year. And we tested it with the possibility of caption of that model, because Blip2 can also caption images, and under a setting of visual question answering. So we asked Blip2, what is the image what is the object in the image, okay? And apparently our model works very well, and it's very competitive with respect to BLIP2. And in most of the cases, it also surpasses their results. So just to summarize a bit what I said, we are proposed what is called a vocabulary-free image classification. So we are basically introducing a new task that is completely training-free. So we are leveraging some training that has been done on those models that are there. They are already available, so you just can pick them, pick the one that you want, and you can apply cased on one of those. And foremost, also, it's open source, so our data and our source code is available everywhere, right? So, of course, our model has also limitation. So, for example, well, the classes must be present in our text database, right? So if our nice Cassowary was not present in our database, of course, we cannot retrieve it, right? So our nice bird wouldn't be called Cassowary. There is no track of output history. This means that we cannot, dialogate with our model. Our model will just work at sample by sample. So we cannot, unfortunately, at the moment, discuss and refine, what we want to get out of this model. Of course, has a problem with slightly different labels, okay? Cassowary may be called Cassowarius, and, there are many different words that this kind of harm the performance of the model if we just want that specific word. And for the same reason, there is the problem of granularity, right? Cassowarius can be also a bird, which is correct. But if the expected result is Cassowary, well, that's count as a wrong. Okay, just to conclude, I want to thank my colleague, Alessandro, Enrico, Massimiliano, Yiming, and Elisa, and of course, our nice Cassowary that helped a lot, at least in the presentation. You can scan it, and you can go on our website. You can find the demo, you can find the code, you can find the data that we used to run our experiments. And also here, we have to thank, of course, the project that kind of founded us, of course. Without those, it would be very hard to do our job. And yeah, I have a short video that shows how the demo works, and maybe we have a couple of minutes to see. It is hosted on Hugging Face platform, so if you go on our webpage, you can just take your image, drop it, right? Because there are some examples, I use those. You can see that, for example, here are those words that are proposed, and you see other words, for example, Colosseum, Rome, Italy, Roman. For example, for this is a desk, cluttered. It is cluttered, messy. Okay, this is a kitchen, right? And so on and so forth. So I think I still have a minute, but I'm done. Thank you.
Thanks a lot. Thanks a lot, Paolo. We have still time for one question, if there is any. Nobody interested in more details about this work? If not, I would like to thank you, Paolo, for your nice presentation. Wait.
The comparison between the Power Horse with your technology in comparison with the other that you have already tell about.
The comparison?
See, for example, there are 500 GPU and here how much?
Yeah, I mean, the point is that our model is pluggable to any of those in any case, right? So our model is like on top of those somehow. But then they are not really doing vocabulary free. They need to be, fed with some vocabulary. So without that, I mean, they cannot do what we are doing, right? But anyway, our model can be plugged to any of those. Of course, if next year a new model will come up, will be very good, but our model will still be able to be plugged to that.
Okay.
Thank you.
Thanks a lot. Now we make a little bit longer break. So next speaker will be at 13:20. So you have 25 minutes of break. And then we have the last speaker of this AI track. Thanks a lot. Okay, so welcome again with our next speaker, the last speaker of our AI track, Markus Bobitzer from the ETH Zurich. And topic is image generation and diffusion models. So Markus, please, the floor is yours.
Thank you for the introduction and good afternoon. So the image you see here is completely generated by an algorithm. The only input I gave is the text on the bottom. So standing on top of the highest mountain, looking down on the other peaks, Alps, an award-winning landscape photo of South Tyrol. And today I want to show you how algorithms can generate images like these. And maybe if you're interested, you can also try it out afterwards on your own. So I'm talking about image generation with diffusion models. A diffusion model is nothing else than a name for a machine learning pipeline that can generate images. I will give you a brief high-level overview. So how does the diffusion process work? Imagine we have like an algorithm that takes in a noisy input and removes a bit of noise each iteration. This is called a diffusion model. In our case, we're talking about images. So here on the left, we have a completely noised image, and then iteration after iteration, this diffusion model removes noise from this image until we get a realistic looking output. This is quite a costly operation. This whole pipeline has a lot of parameters, so it's big. And in the beginning, we needed to do a couple of thousand iterations. One specific implementation is the so-called stable diffusion. Stable diffusion improved upon this initial idea by making the whole pipeline more efficient. It's still very costly. However, you can run it on your own device. And in addition, it also added what we call text guidance, or you may all know as prompt. So you can add a text, as we see here on this example, majestic royal ship on a calm sea oil painting, and you may get a result like shown on the right. This is a sample that has like that stable diffusion produced. Nevertheless, it's a very costly operation, and I want to show you some other aspects such models can do. As we see here, this is a data or like an image augmentation application, and we can not only generate images, but we can also augment, so change already existing images. Let's take a look at this dog sitting on a bench. We can now specify where exactly this dog is by a mask and ask this pipeline, so this machine learning pipeline, to basically remove or change the part defined here with something we defined through text. So we asked it to generate a cat sitting on a bench, and it produces this output. Please note that it completely tried to naturally fill in the gaps as you would imagine from a real-world image. This whole image understanding that these models learned comes with a cost, and namely the training cost of those models. These models are big, as already mentioned, and I think also a lot of other talks today have shown this. For the training data, we needed to, the researchers needed to gather billions of images. And with each image, they had to provide a text describing it. So you can imagine this data set, so like this training data, is immense. And at the same time, they used a whole cluster of GPUs for the first version of Stable Diffusion, around 250. And the whole cluster had to train for a complete month. The estimated costs are in several €100,000. There are several applications from different companies that provide such image generation models. They often build up onto similar or same architecture. However, because their training costs are so high, often those applications like DALL-E or Midjourney are kept behind an API and user have to pay or cannot access the model weights freely. However, with Stable Diffusion, so like the model I introduced before, the researchers, so like the creators, openly released the model weights. That means the whole algorithm is accessible for everyone. And researchers and the community worked with this accessible code software and made it faster, so they made it more efficient. So nowadays you can run it on a GPU that has around 6 GB of VRAM, at least the first version. At the same time, they also introduced some new applications, some new features. As seen here, we can go beyond this text guidance. We can also nowadays input something like edges. So here we have an input image. So this is like the input to the model, edges from this clock tower, and the output are all images that follow those edges, but we still can specify with text how the general scene should look like. So should it be like in the desert, should it be like an oil painting or something like a normal photograph? So this combination and improvements, I don't think they would have been possible in such a way without providing complete access to the model, providing complete access to the whole pipeline like Stable Diffusion has done. I've shown you a lot of nice looking images. I've shown you some good examples, but there are clearly some shortcomings. So one of the most notable shortcomings is this fine details. So as an example here on the left, we see that it cannot produce legible text. Even though some newer models claim they have solved this problem, it's still hard for those to produce good results. At the same time, if we improve even more and the outputs become more realistic, we face another challenge, namely, how does a human decide between real and fake content? So if you see here like a person, is this like a real image? Is this a generated image? And I think like this generated content can mislead some people. So there's also a lot of work in figuring out how to solve such questions. For me personally, I'm very interested in the possibilities with such models, with such generations, and I'm also a bit asking the question, so how does the computer, how does this algorithm imagine our world then? Clearly, it's just basically a statistical approach to images that it has seen through the training data, but nevertheless, for us, if we can add a text prompt and we can get a realistic looking image back, we still can ask the question, so how does the computer imagine our world? So when I asked the model how it thinks the Alps here in South Tyrol look like, such images were generated. I find them very stunning, and maybe you do too. So if you want to try it out on your own, there are like several applications online that you can use. I've also mentioned some before, like Dolly or Midjourney. But I have also prepared a small GitHub repository. So you can either go to this website or scan the QR code, and it will lead you to a GitHub repository that contains a Google Colaboratory notebook. This is basically nothing else, or like nothing more than some Python code that you can run on hardware provided by Google. So you can use your laptop and basically generate exactly this image on the left here on your own device with the hardware from Google. Please make sure to select a GPU, since nowadays if we talk about machine learning, all the computation is done, or like most of the computation is done on GPUs, since this makes it a lot faster. For me personally, I think it's a great opportunity, and I like to do research in this direction, see what the future brings us. Maybe we can continue from generating images to generating videos. Maybe one day we have like content on the mainstream media that is generated by algorithms. Nevertheless, I hope you got like a small overview what can be done. I've shown you some applications, and now I'm open for the questions from the audience.
Yes, we have still a few minutes for questions. Please, wait the microphone.
Do you have any hard numbers about how big the current model of Stable Diffusion is and how much RAM it is required to run it on a PC?
So I think the current model, so I've shown you the Stable Diffusion 1 training process, but the current model of Stable Diffusion is called XL. It can generate images, so like a natural resolution of 1024 pixel by 1024 pixel. And I think the model, so like the parameters alone, are around 4 or 5 gigabytes, if I'm not mistaken. So this is just the parameters. For running this model, I'm not completely sure if it's the most efficient possible way, but I think you need 12 gigabytes. The previous version was at least 6 gigabytes. So if you have a good gaming computer, you can run it locally. There are also UIs, so like user interfaces, that make it a lot easier. And maybe you need to install some other packages. But this is around the numbers. So like the first version, 6 gigabyte of VRAM, and then the other ones around 12.
Thank you. Other questions here?
Do you know which kind of images, what was the data set it was trained on? I mean, I guess it was like cleaned of several kinds of bad images, but can you comment about that?
Mm-hmm. So like the initial version, Stable Diffusion version 1, was trained on Lion 5B. That is like an open source data set collected from the internet. So as you can imagine, you find everything. You find explicit content, you find all kinds of things. They try to filter it out, but since there are like billions of images, it's not completely secured that that nothing bad is in there. The first version of Stable Diffusion was mainly meant for researchers, and I think you were able to create explicit content. With the newer version, to try to mitigate this, but it's still possible, and especially since people can take these model weights and train on their own needs, you can basically create whatever you want. So this is like also a downside of this open source aspect.
Thank you for the presentation, very nice, very interesting. I would like to know if the model generates only still image, or maybe can it generate images that, for example, an ocean in movement, or only still images? Thank you.
Thanks for the question. So the model, so like the general pipeline I've shown you here can only generate still images. However, there's research now going on that does exactly what you have mentioned. And the example of giving like some basic motion with waves is possible now. There's also like a zoom in, zoom out factor of a portrait possible. Clearly, the main problem with this is so like if you generate several frames, so like a video is several frames, the consistency between the frames is not always kept. This is something where we have to work on.
Okay, I don't see any other question. Have a final one. So if you have, for example, a specific object for which we would like to have an image, like, for example, at a hotel, could we use this kind of models to generate an artificial photo of this hotel if we train it in a proper way? So
Absolutely, yeah.
Do you think it's possible to, would you do that?
So I know from a paper that basically, it was actually for large language models where they fine-tuned some specific model weights in the whole pipeline. to do exactly what you have mentioned. You can put in 5, 6 images of a person, of a hotel, whatever you want, and you can fine-tune it such it generates exactly what you this kind of color.
Interesting. Okay. So thanks a lot. It was the last talk. Thanks a lot, Markus, for your presentation. The AI track is now completed. For who is interested, here we will start at 14:20 with a legal track. And so enjoy your conference with the next speakers. Thanks a lot for your attention and for your participation.